Hi everyone, my name's Paul Richardson and I'm the module leader for Fundamentals in Design and Statistics. This is a module in which we teach you the kind of the core areas, the real kind of building blocks of statistics as required by the British Psychological Society. So what I'm going to do in this screencast, you've already had one on basic research designs. And so this one is going to be pretty much what we focus in on the workshop. So next week you'll have a 2-hour workshop online over Zoom, and what we'll do is sort of go over the exercises in your workbook in those and get you hands-on with Jamovi, which is the software package you're going to be using all throughout the semester, learning how to instruct that to do all the kind of the heavy lifting for statistics for you. So one of the things that I've already sent out in the previous announcement is making sure that you kind of familiarize yourself with the Blackboard site. And as part of that, one of the things that I've done is on the module guide, but also how to use this site, is just giving you some kind of information. So the teaching format specifically for FDS, because of the recent kind of restrictions, what we have catered for is to have the majority of those as online. And so these will be delivered live either on Tuesday 1 o'clock till 3 o'clock or Thursday 9 to 11, depending on which course that you're doing. These will be delivered live over Zoom. And so you'll know from your timetable who your tutor is. So again, if you just go to the staff details website, you'll find out what their Zoom link is. And I've also repeated this at the start of the learning materials folder. So again, you'll find out who your tutor is. Click on the link and you'll be sent to the Zoom room. Please make sure that you've got the latest version of Zoom available on your computer. Previously, we've had issues where students have been using outdated versions, and so it doesn't allow you to do various things. So please make sure that you have the latest version of Zoom available. What I would also suggest as well is, because we're using the Jamovi software to do the analyses for us, it helps if you have the latest version of Jamovi as well. I've already sent out previous announcements about how to get hold of this, but please make sure that you have access to a working version of that software. If you use kind of older versions, then certain features might not be available to you, which is why I would always suggest that you get the latest version. I believe currently it's on 1.611, but make sure that you get the current version. So the teaching format, yes, we're going to have weekly 2-hour sessions. Majority are going to be over Zoom. Hopefully we'll get at least at some point in the second semester the chance to see you guys face to face. But they're going to be delivered online live at the previous times I've mentioned. But what we'll also do to help support you in the learning, I will be doing these kind of pre-recorded screencasts such that these will act in effect as your lectures. So that way I will always release these on the Friday before. So you'll have at least the weekend and a few days of the next week before you actually turn up to the session. But I will always assume that you have access to these screencasts and look through the slides, any kind of reading material that we might have suggested before you attend the session, just so you're not kind of learning on the fly there. It might get a bit bumpy otherwise. One of the things that a lot of people dislike or think that they might dislike about the statistics module is obviously because it involves maths. There's numbers there. Maybe people weren't confident about the maths that they did at secondary school or at college or even at university, and therefore you might be somewhat have some anxiety about learning this particular module. And what I will say straight off the bat is, well, yes, statistics obviously does have numbers involved, but the amount of mathematical knowledge that we will require you to have is pretty minimal. And as you'll see, you can hold me to that. As we go through the semester, what you will find is basically you're comparing, the value of one number to another pre-specified number. Is it more than? Is it less than? Or if we demonstrate in certain things, then you might, divide one number by another. But you can always use a calculator for that. Years ago, we used to teach statistics all by hand, and it was horrific. It'd take people hours to work out calculations, and it was silly. We've got software that can do it for us in a matter of seconds, and therefore we're going to stick with that. Obviously, it's useful perhaps if you know what's kind of going on behind the scenes, but we'll explain that to you in a conceptual manner. So rather than getting you sort of up to your elbows in numbers and decimal places and so on, we'll teach it to you from a very kind of pragmatic sense. So once you get the concept, once you understand the gist of what the statistic is doing, things should begin to click more into place. In terms of the assessment, there are two for this module. We have a research report, so we'll get you to undertake a piece of research during the course of this semester, and you then merely write that up using the standard report format, which is the basis of the kind of papers that you've been reading in journals all throughout your studies so far. And we'll also have an exam as well. The exam is online. You won't need to do any analyses yourself. Everything will be, any analyses that have been involved have already been done for you. What we're more interested in seeing is how you can interpret those. This exam is over the course of 24 hours. So release it one morning and you have until 24 hours later to submit your answers in a Word document. I'll talk more about the assessments as we sort of get nearer the time. Finally, a lot of students tend to question, do I have to attend every session? And I would say right from the bat, we might not necessarily expect you to attend 100% of your sessions, but you certainly cannot pick and choose which sessions that you go to. I know with some other of my colleagues' modules, what you can do perhaps is pick and choose which are the ones that seem more of interest to you, the ones that kind of maybe reflect what you're going to be doing on the assessment. But that won't work with statistics. Each week we kind of build upon what we've done in the previous week, and so what we're doing essentially is laying down a foundation and then going on to refine it and extend it in different ways. If you find that your attendance is going to be a problem, as much as we can support you with the pre-recorded lectures and these lab sessions, if you're not attending the online workshops, the lab sessions, you might find you really start to struggle. So please make sure you access all the materials and that you do attend as many of the workshops as possible. Okay. I forgot these things as well. So yes, research report on, well, what would have been a 1-hour exam, that was last year. So I'll just take the opportunity to change that. 24-hour exam. Everything is good again. Hang on. Bingo. Right, we're back. So yes, it's a research report on a 24-hour exam, and yes, I would suggest try and attend as many sessions as possible. Okay, so starting off then, obviously, if you've done a study and you've collected some data, brilliant. Your database, all your kind of scores that you've obtained from your participants might look something like this. Okay, so we can see we've got a load of kind of, let's say we're selling different posters. Okay, so these are the contents of the different posters, whether it be rap stars, different types of cars, animals, and so on and so on. And we can see on a monthly basis how many have been sold. I've never yet come across a research study in a journal that shows you raw data like this. Unless you've got a very keen eye, it's quite difficult to make sense and spot any kind of trends or be able to kind of, compare different groups with each other. it's just too much all at once. What we need is some way to try and summarize this and be able to describe it. And that way it makes things a lot more kind of easier to work with. And so that's what that is what we're going to look at in today's screencast. And again, in the workshop next week, we're going to focus in on actually doing these descriptive statistics in software. So make sure you've definitely got a copy of the Jamovi software on your computer ready to rumble. So there's three different types of descriptive statistics that we're going to concern ourselves with. We have the measures of central tendency. So in essence, you can think about this as the kind of the averages. You know, how well do people or groups, how well do they do on average? What's the typical score or the typical level of performance? We also have measures of dispersion. If you think about it, knowing on average how well people performed is all well and good, but not everyone is going to score that average. There's going to be, some people scoring below and some people scoring above the average. And what we need to have is some sort of idea of this dispersion. How widely spread were the scores around those average scores. And so that's something we can look into. And finally, we can also have measures of distribution as well. What does our data look like when we begin to plot it out? Does it have certain kind of parameters and properties that indeed we can take advantage of? So what we're going to look at this week is how to calculate these type of things. And then in the following week, the following session, what we're going to do is how to visualize these. And we can make or take advantage of certain kind of built-in features in Jamovi that can then plot out or draw various graphs and figures to help us consolidate that level of information. So, again, we're going to concentrate on the averages to begin with, the central tendency. Where do people tend to lie? So, to begin with, whenever you mention the average to most people, intuitively they think of the mean average. And so this is simply, the total of everyone's scores divided by how many people there are there, how many participants that you've got. And so that way it kind of takes into account everyone's scores, the value and range of everyone's scores, and comes up with a single figure to describe the average of all those participant data points. Very, very useful metric. As you'll see, it does have some drawbacks, but it's one that's most often reported, and it's very, very intuitive in terms of understanding that. Alternatively, you have the median average, and this is essentially the midpoint, literally the midpoint of all your numbers. So all we do is have all our data and just rank them in ascending order. So start off with the lowest numbers and build your way all up to the highest numbers. And then literally you find the midpoint and choose that one. The job's done. And that way it's definitely sort of like the half or the midpoint of your data. Finally, we have the modal average. And this is where, again, you have all your numbers and you just record which is the one that occurs the most frequently. Which is the number that most people have reported as having obtained. Whichever number that is, again, that's going to be your modal average. Now, for the most part, each of these three different averages, and believe me, there are many more different types of averages that we can report, but certainly in psychology, these are the three that we tend to report the most. Anything else tends to be sort of more from the world of physics and engineering and pure maths and so on. So, for the most part, these three averages tend to overlap or are very, very close to each other. But sometimes, depending on what your data looks like and what properties it has, sometimes these three averages can differ. Sometimes that difference is negligible, it can happen by chance. Otherwise, the differences can be quite large. and therefore you might have a set of circumstances in perhaps which one of those averages might be better or might be more representative of the average score than some of the others. And we will come on to that in the session. But again, just to reiterate what we've done here, if we want to work out the average of a data set of scores, we simply add them all up and then divide by how many we've got, and that will give us our mean average. If we wanted to work out the median average, all we would do is rank all our numbers, starting with the lowest, going all the way through to the highest. So that's what we have here. And all we do then is simply find out what the midpoint is. So this 7 is the midpoint here. Sometimes you might find if you have an even number of numbers, then it might be between, your median would be between two numbers. And so all you do is find the midpoint of those two numbers. And finally, with the modal average, we just report which is the one that's most commonly occurring, and that will tell us what the modal average is. As I said, more often than not, these averages are very, very close to each other, but occasionally they can begin to separate and return different values. And this is particularly true if you have a small number of participants in your study. As you can see here, I have 7 participants, and we can see we've got 3 different values for each of those 3. A different value for each of those 3 averages. And this is because, if you've got a low number of participants, you might have, or you're more at risk of kind of spurious results happening due to 1 or 2 participants. However, if you have a larger number of participants, then any kind of idiosyncrasies tend to be lost amongst the volume of all your participants. And so this is, again, it's another reason why there's always safety in numbers. Quite often, once you sort of get above kind of 50 participants in the study, just a rule of thumb there, then you might find that such problems tend to disappear or be less problematic. So always be wary of studies that have a small number of participants. Again, as we'll see over the course of this semester, you're just more likely to have difficulties arising because of that. Another example could be if you have extremely high or low scores. That can affect the averages. If you think of the mean, because that takes into account the value of every single number. Let's just say that this last number wasn't 8, let's say it was 80. All of a sudden, your mean is going to be hugely different because of that one single value. Whereas in the median, if that 8 was 80, wouldn't make a difference. It's still going to be 7. And again, in one of these, the modal averages, let's just say this 8 was 80. Well, in this instance, we wouldn't really have a modal average, simply because each number has only been reported once. And so the default there is simply to report whatever is the lowest value. But strictly speaking, there wouldn't be a modal average. But it just goes to show how things like extreme high or low scores, what we might term as outliers, can be particularly problematic for data sets, particularly small data sets. And so therefore, one of the things that we're going to teach you to do is always check your data. Always look to see if there might be any kind of spurious cases here that might then be throwing off our analyses. If we have any analyses that are built on the mean in that particular instance, then obviously going to become less reliable. If the mean has suddenly jumped up to, I don't know, let's say it was 22 or something, well then that simply wouldn't be representative of all those other scores. And so therefore, if you've got extremely high or low scores, you have to be particularly careful when using the mean. Sometimes it might be better to use the median instead. And this is one of the things that we'll come to learn, particularly next week, when we begin to plot out our data they tend to conform to certain properties or certain distribution patterns. Typically in the sense that you have a very small number of low scores, a very small number of high scores, and most people tend to score around the average. And so you get like a typical type of distribution. This is what's known as a normal distribution, and we'll talk more about this sort of next week when we get to plot out data. But sometimes if your data isn't normally distributed, then what can happen is your mean, median and mode can begin to separate and spread out. So again, it's one of the things we'll pick up on next week when we visualize our data, how you might be able to spot that. But again, we can look at that when we calculate our values. So what I've just demonstrated there was, doing some basic analyses in Excel if we had 7 scores. But it's highly likely you're going to do any research with just 7 participants. More often than not, it's going to be something that's sort of nearer akin to 70 participants. So you can imagine trying to do those calculations by hand or even in Excel, trying to set up all the formula for these things can be quite difficult. And they can be rather limited in their approach and all the features that they do have. So what we do take advantage of then is more specialist software. And there's a variety of programs that exist out there that can do all this kind of number crunching for us. There's things like, the SPSS is one of the most common ones by IBM. Or we have other programs like R, Minitab, and SAS. And these are all fantastic. But one of the things that we would suggest is that for those of you that are familiar with those programs, the interface is rather clunky. And so what we've been using for the past 2 years is a program called Jamovi. And this is a very, very kind of intuitive piece of software, albeit with some training, that you can use to do your analyses for you. And this is something that we're going to be using each and every single week in the semester. Thankfully, you can install it on your own computer, whether it's a Windows, whether it's a Mac, it's a Linux, whether it's a Chromebook, you can install a free copy on your computer. There's also a version that you can use on the web as well. You can run in a browser, which is again, it's amazingly fanciful and unique thing to be able to do. Just be aware that if you don't press any keys for 5 minutes, it'll kind of lose all your data, so you need to type it all in again. But please make sure you've always got the latest version of Jamovi. Like I say, if you happen to be on campus, then it's installed on all the computers there. You can download it for your own computer. Like I say, you can run it in the browser. But just please make sure whenever you attend a session and we're going to be studying statistics, that you have access to a running version. Okay, so obviously, if you're at home now, you might have installed Jamovi. It might look a bit weird and wonderful. You're not really sure sort of what to do, and you think, hey, that Paul's lying. It's not looking intuitive. So one of the things that we'll do right in the first session is show you how to use it properly. But just to give you a heads up now, basically, if you do happen to poke around and have a look at Jamovi, and I would strongly suggest that you do, rather than be kind of have any kind of anticipatory anxiety or fear about statistics, I'd much rather you think of this as just an opportunity to learn, just to see what it is that you're going to be doing. You'll surprise yourself sometimes. You'll find out actually you can have a quick play around and you might know how to be able to do things. There's nothing that can go wrong with this software. You can get it, as you'll see, you can get it to do certain things. If you don't like it, you can just delete it and start again. It's purely doing what you tell it to do. Okay? And so one of the things I want you to sort of feel is more confident about this. And so we'll take time on the first session for you to have a play around with this and just get comfortable with the setup and what you need to do. We'll teach you how to use it And so this is something that you'll find really sort of quite, well, hopefully quite empowering, but certainly very, very useful in uncovering your statistical analysis. But to start off with, in this left-hand window, that's where you're going to type in all your data, set up all your variables for your database. And in this right-hand window here, any analyses that you've done, any kind of calculations, any graphs that you've drawn will all appear here. And so it's all linked together, and that's got several advantages that will sort of introduce you over the course of the semester. Okay. Again, in terms of creating new variables, this is something that we will show you in the first workshop. But again, if you want to sort of have an idea and have a play around yourself, by all means do this. I will be recording screencasts showing you how to do all these things. We will show you how to do it in the work session, in the workshops. But again, sometimes just having a crack yourself just might sort of give you the confidence to think, yay, I can do this. So in this window here, I've just shown you that if you click on the data tab and press setup, one of the things you can then do is start to name what your variables are. So this window should drop down here, and for column A you can type in the name of your variable. You can give it a more detailed description if you want, and we can play around with the type of variable that it is, and so on and so on. We will cover this next week, but just have a go and see if you can get with that. Sorry, the dogs are kind of staring at each other here. Oh, okay. Okay, so in the workshop then, like I said, we're going to start off with showing you how to create a database. We're going to show you how to set up some new variables. And in the workbook that you've got, you'll have some data, and that is what we will use. Okay, so it's just two variables. We'll look at the sex of a participant and how far that they've travelled to Sheffield Hallam that morning. A bit redundant now, not think about it. How far is their home from Sheffield Hallam University. And we'll show you how to create these variables, how to input the data. There's also a cheat as well, where rather than sort of typing in all the data, you can just copy it directly from the table in the Word document and paste it into Jamovi. So it will show you all those kind of useful tips. And then we'll start off by running some descriptive analyses and sort of get you kind of more familiar with what we're doing. So as you'll see, one of the things that we'll do first of all then, if we want to get those measures of central tendency, again, Jamovi will run a whole batch of things for us, but you can pick and choose what is it specifically that you want to see in your output. And so I've previously mentioned what your three measures of central tendency might be, and so we can just choose those three. So let's say I've already looked at some the data for the distance to Sheffield Hallam, and thank you. And we've got the mean, the median, and the mode. So this isn't the data we were looking at previously. This is what we're going to be using for your workbook. So we can see, like I said before, typically the three averages tend to be very, very similar to each other. And, we have that here. We've got a mean average of 6.7 and a median and modal average both reporting 7. Brilliant. So that is quite simple and straightforward. If you get that from your output in Jamovi, you can then just copy and paste that table directly into your workbook in Jamovi. And I would say, I really want people to engage with the workbooks and complete all the exercises. The whole point of the workshop is, well, the workbook is to help you sort of develop your skills on a week-by-week basis. And what you'll find, if you collect and do all those exercises, obviously as your knowledge begins to increase, what you're actually making for yourself is a revision aid. And so when it comes to actually doing the exam, in May, you'll find that you've got a brilliant resource there to help you guide your revision. Okay, so what we've done here, I've looked at the descriptives for all of our 10 participants all at once. But maybe one of the things I wanted to do was break it down and look at different groups. So one of the things that I mentioned was, just move my face. One of the things that I mentioned was that we can also sort of break it down into different groups. I mentioned previously about having males and females. So what you can also get Jamovi to do is give you those same 3 descriptives, but just split that by what group people are in. So here we're just looking at the different sex, male or female, and we can see again by and large the numbers are fairly kind of similar, which typically tends to be the case, but not always. And so just in a quick change, I can go from either having an average of all my participants or something more specific per group. But as I said, the measures of central tendency are all fine and well. Knowing how what the typical score of participants would be can be very, very helpful. But not everyone in a group, or not every participant, scores the same as the average. By its very definition, people are going to be either above or below the average. And so sometimes what we want to know is, how much do people deviate from the average? How much do they score above or beyond, above or below the average? Is it a little? Is it a lot? If we've got a huge big spread of scores, then that indicates that not everyone in the group is not everyone in the group is scoring quite consistently. There's a lot of kind of variability within the group. If this dispersion is quite small, and the scores are indeed quite close to the average, then it indicates that everyone is scoring very much pretty similar. And so again, the dispersion can tell you some additional information that perhaps the central tendency or the typical score cannot. And so it's possible to visualize this. We can show you different graphs and how you can represent this, and we'll cover that in the second session. But for now, what we're going to focus in on is calculating some more descriptive statistics. So again, what you will see here in Jamovi, where have we gone? What we can do in Jamovi, I have to bring this back. Well, I've disappeared. Oh, I'm back again. What we can do in Jamovi again is ask for a variety of different kind of measures of dispersal, be it the kind of variance or the standard deviation or the interquartile range, etc., etc. And in the workbook, I talk more about these individually. But again, these just indicate by how much scores aren't typical, how much they deviate or spread around those averages. So if we think of the variance, then what this represents is if we look at each participant on their own and calculate how far from the mean is that one individual. What we can then do is square that person's score and do that for everyone else as well. If we don't square it, what tends to happen is, because some people are above the mean and some will be below the mean, they'll just cancel each other out and end up with 0. So if you square that number and then add them all together, it kind of gets rid of that problem. And what we can then do is divide that by the number of participants minus 1. We divide that by the number of participants minus 1 because we're talking here about a sample of participants rather than the population that we're going to start to make inferences about. And so this minus 1 just gives us some wiggle room. We'll talk more about this in a later session. But what it can do then is tell us on average by how much do people kind of square deviate away from the mean average. And so we can see that represented here. But the problem with talking about square deviations is that it's not very intuitive. So instead, rather than talk about the variance, what we can do is talk about the standard deviation. So just find the square root of that variance, gets rid of the square deviations. And so here with the standard deviation, all we've done is got the square root of the variance. And so this means on average, whilst the average score, or the average distance that people lived from Sheffield to Hallam was 6.7 miles, on average, people deviated by 1.49 miles. So the average kind of one standard deviation above or below the mean was 1.49 miles. So it gives you an indication about how much spread in the scores is there. And typically the mean and the standard deviation go together because, as you can see from the calculations, they're pretty much pretty much dependent on one on the other. Alternatively, sometimes we might report the median instead, and what we conventionally do is report the IQR with that, the interquartile range. So all we do with the interquartile range is kind of divide your spread of scores into 4, from 0 to 25%, 25 to 50, 50 to 75%, and 75 to 100%. And all we do with the IQR is simply find that middle 50%. So from 75th centile to 25th centile, do the subtraction, and that'll tell us what the range of scores are. So typically it tends to be very, very similar to the standard deviation. So it's kind of like the analog version, so to speak. And again, we could report that the median number of miles people lived from Hallam was 7, with an interquartile range of 1.75. So it tells us, what the typical distance was. But again, it gives an indication about how much difference or how much spread there was, or deviation in those scores. So what does that mean, really? Well, when we talk about kind of scores being spread out, so to speak, let's say that I'm doing a study and I'm checking out the speed of cars as they drive down my road. I could stand out on one corner with like a clipboard and a speed gun and just log each car as it drives down, how fast is it doing. So first car comes along, it's doing 30 miles an hour. That goes in the ledger. Next car comes along, doing a bit much, doing 55. Next car 25. Next car was doing 20. Another one doing 50, 45, and so on and so on. I've started to build up a pattern of how quickly they're driving down my road. And typically what you tend to find is that if you've got enough cars or enough participants in your study, then your data typically takes on this shape, this distribution of cars. So again, we'll see here that there's very few people who trundle along at 5 miles an hour. Equally, thankfully, there's very few people who zoom along at 55 miles an hour. Most people are kind of obeying the speed limit, and they kind of be represented by the average, by the central tendency. So if we think of the averages then, the mean, the median, and the modal average, then typically they would all align and be around about the same figure. But obviously, not everyone that we can see here is scoring the same. Some drive slower, some drive faster. And so the variance gives us an indication by how much variation there is in speed. Again, if we take the standard deviation, or the square root of that standard deviation, then that would mean, kind of on average, by how much people are going above or below the average. Similarly, with the interquartile range, again, that might give us a very similar figure about how much the spread of scores around the median average. So all we're doing here for the central tendency, for the average, is finding out on average how quickly people are driving. whereas the standard deviation and the IQR tell us about how much scores are dispersed around that average. So again, both are very, very useful metrics. But occasionally, you might find that there's one car or one data point that's so unlike everyone else. There's something different about this participant or this vehicle. Could be, that there's a genuine reason as to why that is. In the case of an ambulance, you might say, well, he was speeding down there to get to a hospital, therefore it's not a typical car. It's not like the rest of the data that we would have collected. It's just a spurious one-off case. There's an argument to be had, well, because it was so spurious, because it's so unlike everyone else, do we then kind of like snip that out and not include it in the analysis, so just exclude it? Do we keep it as it is? It was a genuine vehicle speeding down the road at that point. Or maybe we transform it somehow, so maybe we could say it wasn't doing 70 miles an hour. Let's say it was just doing one more than the fastest one, so it's still the fastest vehicle. There's a whole range of arguments as to what you can do with this. And what's important to know in statistics is that there's no right answer. There's no right or wrong. There's a variety of different things that you could do, and just outline 3 of them there. But what we're going to be interested in, and certainly when it comes to your research reports, if we do notice that there might be problems in the data such as this, what we're interested in is your ability to justify what decision you took as a researcher to do with that problem data. And that's what we're interested in. I talk about these kind of dispersions and so on. As I say, typically that's what most data looks like. If you're measuring people's hair length, their height, how fast people are driving, personality traits, whatever the kind of metric, then typically it tends to conform to that kind of bell-shaped curve, the normal distribution. All it represents is that there's very, very few people who have low scores, very, very few people who have high scores, and most people are going to be sort of, around the average. In fact, as we've just kind of learnt there, this red thing here reflects one standard deviation above and below the mean. And so typically, if our data is normally distributed, we might get around about 68% of our participants being within that one standard deviation of the mean average. You can also extend that away, and if you sort of incorporate, the 2 standard deviations, then you're going to get about 95% of your participants. And again, if you include the blue, the 3 standard deviations, you're looking at, well, just over 99% of your participants' data are going to be within that kind of era. Again, you might find that you've got the ambulance of the kind of the one-off thing that seems to be spurious, that's going to be less than that. And that suggests that really maybe there's issues with that score, that is so extremely high, or equally it could be so extremely low that it stands out. It's different from the rest of this distribution. Again, that can tell us things about what to do next in terms of our analyses, and so we need to sort of be aware of what our dispersions and distributions look like. One of the things that we can also begin to do is look at the shape of this distribution, and that's what I want to look at now. So again, if I just move my mug over. So we've already looked at central tendency, we've looked at dispersion. What we're going to look at now is the distribution. A lot of our statistical tests, and these are what is known or referred to as parametric tests. In other words, it seems that your data meets certain properties. These parametric tests rely on your data having certain kind of characteristics, one of which is that your data should have that kind of standard bell curve. And as you can see here, typically when that happens, your mean, median and mode do tend to overlap very, very closely. But occasionally, and that's not always the case. Well, I say occasionally, all the time, you're never going to get a perfectly normally distributed data set, but you're going to get something pretty close to it. And so there are various statistics that we can take advantage of that indicate how close is our data to a normally distributed data set. And the two that I'm going to show you are called skewness and kurtosis. So, skewness is referring to the degree of symmetry in, pardon me, the degree of symmetry in your distribution. Ordinarily, your distribution of scores would be like a mirror image. So if you think of the average as splitting it down in two, then normally your data would be kind of pretty much a mirror image of two halves. But occasionally, you might find that the data is kind of sloping off to one side. It becomes asymmetric. So we can see here, in actual fact, the mean average, the central tendency has been pulled across here. And you've got a big extended slope. We've got more higher scores than perhaps you might anticipate. So if you can imagine on this normal one here, all that's happened is we've got a higher or more higher scores than you would anticipate. And this just indicates that we have positive skewness in our data. Again, you could imagine the opposite of that. You would have negative skewness and you've got more lower scores than you might anticipate. Again, don't worry too much about these graphs at the moment. We'll look at that in the second session. What I want to sort of focus in on is the actual skewness itself. It just indicates that you have a lack of symmetry about how your data is distributed. Other things that we can look at as well is kurtosis. And this just is how kind of pointed does your data look. Whether it's kind of more like a normal distribution, where it's that kind of bell-shaped curve, or perhaps is it really sort of quite pointed, quite a sharp thing where it's known as leptokurtosis. Or equally it could be sort of more flatter. And so this would just indicate, how your spread of scores around the averages is going. Typically, the average scores very much overlap, but what you tend to find is a wider spread of scores. This example here is a platykurtic distribution, whereas this one here, because it gets more and more pointed, more and more people are around the mean, which indicates we have a leptokurtic condition. And so whilst I'm showing you the distributions here, one of the things that you can actually do in jamovi, face is in the way again. One of the things that you can do is choose what these different measures of your distributions will be. So you can get it to tell you how much skewness and kurtosis there is in your data. So, for example, again, each of these things are just going to be added on to your any kind of descriptives that you've already requested. So I'll just move my face yet again. So if we've already requested these descriptives, anything else that we sort of add on gets put on at the end of that. So we've got these values of skewness here and kurtosis. And different books might indicate different things. For instance, the Dancing Reader suggests if you've got skewness or kurtosis levels that are greater than +1 or -1, then you might have an issue. If your data is perfectly symmetrical, you would have skewness of 0. If your data is just the right height, it would have a kurtosis level of 0. But if you've got more than +1 or less than -1, it indicates you might have an issue. Alternatively, if you read the Andy Field book, he suggests what you should do instead is divide the skewness by its standard error. We'll talk about standard error later in the semester, but think of this as a kind of a degree of measurement error. How close our participants, our sample, is to the population that we've gotten from. The smaller the standard error, the more accurate or the more representative your participant sample data is. But all we do is divide the skewness by its standard error. And if you've got a value higher than 3, strictly speaking, it's 3.29, then that is where you have problems. So again, there's different things that you can do. One of the things we also looked at here is this Shapiro-Wilk. And so I'm talking about, we can have measures to decide whether or not our data is normally distributed. What we can also do with this Shapiro-Wilk, if we request it, what we can also do essentially is compare the distribution of our data set against one that is perfectly normal. And that way we can do a quick analysis to see, is our data significantly different from this perfectly normal distributed data set? So for instance, in this data here, we're looking at the forearm length of bats. And we can see the kind of the shape that it is here. And I've superimposed on this blue line here what a normal distributed data set would look like. And so one of the things we can do is simply have a comparison as to whether or not there's a significant difference there. We'll talk more about significances in the second workshop as well. But what I'm trying to get across to you here is a multitude of tools at your disposal that can just help you find out more about the properties of your data. Take advantage of them. So, to finish off with them, the first step in any analysis is always to run your descriptive statistics. Find out about as much about your data as is possible. Begin to explore it. See what values you can come up with. See if you can identify any potential problems that might need to be remedied. And that's it. That's the end of this screencast. All I would do now is say, make sure again you've got a working copy of Jamovi, and I will see you in the workshops next week. Take care.